Who can tell me what the molecules and atoms are like or different in the three states of matter? What are they like in a solid? Who knows? Yes?
In a solid, they're all like connected and like they're like stable. They're not moving at all.
Okay, they can wiggle a little bit,
Yeah,
but they're close, packedly tight together. Look, if I took everyone in this room and put you in the elevator, you would be so packedly tight together. But you could wiggle a little. Maybe you could move your hands and scratch your nose. You could wiggle a little bit. That's a solid. If we invited you here to iFly today to fly on a solid, all we do is have you sit on the table. Boom, doesn't that sound like fun?
Yes.
Now, what are the atoms and molecules like in a liquid? Yes?
Kind of more loosened up, still not too far away.
Excellent. They're kind of floating past each other, but they can't get too far past each other. Like if I took 3 of you and went into the elevator, we could move around, move past each other. Have you ever floated on water?
Sort of?
Yes.
Yeah, you know how to swim, right? You're not swimming today, you're floating. So show me by using your hands what position your body has to go into to float on water.
Kind of spread out.
Oh, I love that. You all spread your hands out. Yeah, you spread your hands out because you want the water to keep you up. And the way you do that is to get as much water underneath you as possible. And all you have is your body. So you spread yourself out, and that is a lot of water holding you up. So gas is very similar. What are the atoms and molecules like in a gas? Yes?
They're free.
They're free. They're spreading out. You give them any room and they will spread out in it. So here's our trick. If we invited you to come fly on a solid, you're already doing it. You're sitting on our chairs. Isn't that fun?
Yes.
If we invited you to come fly or float on water, well, you can all do that in your backyard if you have a pool. But we're inviting you to come float and fly on the gas. The gas that is now bouncing all over. And somehow I got to give enough gas together to lift you up. Because sitting right here, we're not flying, are we? So there certainly isn't enough gas in this room to lift you up. So we had to gather a lot of gas to lift you up. How do the skydivers do it? How do they get all that air and gas to have them come through the atmosphere? Gravity is definitely there, but when they're jumping out of a plane from mile up, there's a lot of air they're flying through, and all that air helps them come down from the plane without coming down too quickly. All that air slows them down. So how do you think we got all that air from the atmosphere to slow you down from falling? What trick do you think the engineers used to get all the gas that's floating around come together and push you up?
I was gonna say they just made a fan.
They just made a fan. They didn't just make one fan or 2 fans or 3 fans. There are 4 giant fans. So let's go back to liquids and solids. They act like fluids. They're liquids and gas, I'm sorry. They act like fluids. A fluid wants to go in a straight line until it hits something. This is the wing of an airplane cut off from the plane. You can see it's coming straight until it hits the airplane. Then it has to go around it, and it does all kinds of swirls. And very up here on the tip, do you see the curly cues? That's the tip of the plane. It's bouncing off the tip of the wing. These days, wings have these little sticks that come up to kind of cut down on all those curly cues. When you're on the plane, that is what they call turbulence. When the plane bounces ups and down a little bit and the pilot says, fasten your seatbelts. So that's caused by the tip. When we made our tunnel, do you think we wanted you to bounce up and down so you needed a seatbelt?
No.
So we had to make it so there was no tips or corners or cracks for the air to bump into. So who recalls what was the shape of the tunnel downstairs? Yes?
Circle.
A circle long is called a?
Cylinder.
It was a cylinder, completely round. No corners for curlicues to happen, so you won't have that turbulence feeling. So, like you mentioned before, there are two forces at work. Gravity, number one force. We're here today to defy the laws of gravity. We want you not to fall because gravity does everything it can to make you fall. Not too many things can defy the laws of gravity. Can you think of something else that can break the force of gravity?
Birds.
Birds, absolutely, love that. A balloon, yes.
Helicopter.
Helicopters, yes.
A missile.
A missile, absolutely. And when we send them onto space, we call them what?
Rockets.
Rockets. All those things need a lot of power, gasoline, fire to burst them across the force of gravity. Then I want you to go to think about a bird, but not the bird, but a bat or a pterodactyl. How would you describe the way they fly? They glide. Yeah, they don't have a rocket coming out of the bottom of them. They glide. They have those big wings. You guys are going to glide on your big wings. But you're not going to be a bird like this. You're going to be a pterodactyl or a bat like this. You're going to bend your elbows. Why am I doing all this? Because when you're in the tunnel and you're not bending your elbows, that guy's going to turn you towards the driver and the driver's going to go like this. To remind you to bend your elbows and keep your fingers out beneath the air to touch every part of you. So gravity, and we're going to use the force of the fan to blow the air up at you. Here are different types of wind tunnels. We've had wind tunnels around for a long, long time. This one's going sideways. Obviously, ours is going up and down. So what do they do with a wind tunnel that goes sideways? Well, they test cars in it. This van is blowing smoke over the car. Smoke is smoothly riding over the hood of the car. We want the air to go smoothly over it. We don't want the car to be hit by air. We want air to travel over it smoothly. Does anyone know what that's called when we want air to travel smoothly over something? All the way in the back, sir. Aerodynamics. Yes. Anything that wants to go fast wants the air to travel around them. What else is going to go fast in this picture? Yes.
The plane.
Absolutely. So they test the aerodynamics of a plane. See this little tip right there? That's what helps with the turbulence. What else is going to go fast in this screen? Yes.
The person riding a bike.
The person riding a bike. Notice his helmet. Does that look like the shape of a car? Because they want to go fast. Do we want you to fall fast? No, because then your ride will be over in a second. We'll be getting you back on the bus and sending you back to school. So our job is not to make you aerodynamic. We don't want you to be aerodynamic. We want to do the opposite of that. And the opposite of that is called drag. Drag is going to slow you down. That's our job here today, is have you fall slowly. We want to drag you down. We want you to go home today and tell your grandmother, because she'll probably be the only one that'll get this, that, how was your field trip, honey? You know, it's such a drag. Because we are going to drag you to slow you down. How are we going to drag you down? We're going to use your body. Just like in this picture, which object is slowing somebody down?
My name's Ellie, by the way. It's the parachute.
The parachute. The parachute is big.
Looks like a donut.
The bigger it is, the more atoms and molecules it could catch. And the more air you catch,
The
that
slower
will
you go.
drag you and slow you down. So aerodynamics wants you to go fast. We don't want that here today. We want you to go slow. So you're going to be using the forces to create that. And this is how your body is going to act like a parachute. Your jumpsuit is big, So that's kind of like a parachute. That's going to catch some air. You're going to have that, might not be comfortable to have your shoulders up like that. Parents, I think all the parents are welcome to fly, but this might be an uncomfortable feeling for a little bit. Goggles, people with glasses, you could choose to leave your glasses on, I'm told. It's just fine. I took mine off. It's entirely up to you. Hands out, fingers out, head up. Your head is kind of like the driver. It steers you. So if your head goes down, what direction do you think you're going to go?
Down.
Down. If your head goes up, what direction are you going to go?
Up.
To the left?
Left.
To the right?
Right.
We don't want you to do any of that. If you come back another time, that's another skill you can learn. But right now, we just want you to keep your head up and straight, yes?
Yep.
Okay, next. Here's another iFly. They're all over the country. They've changed over the years. Ours is one of the newest ones here in Phoenix. And he's talking about the fans that are on top of the roof. They travel down through the building on both sides and then come up in the middle. And I wanted to see if you got a good chance to look at that tunnel. As we walked by, did you look down?
Yes. Yep.
We were standing right there, we saw this. Did you look up?
Yes.
Okay, so do you notice that they're standing on a net?
Yes.
The instructor will be standing on the net. You probably will not. Because when you come into the tunnel, you're going to come in flying. In fact, you're going to assume the position of Superman. And you're going to put your hands up in the air like this, and you're going to immediately come in flying. The instructor is going to be standing there at the door, ready to hold you up as you fly in. Just like when you were little and you jumped into the pool, and Mom was right there, ready to hold you up as you jumped into the pool. So he will hold you until he thinks you might be doing a good job, and then he'll let go. If you get too low, there are straps on back of your jumpsuit to pull you right back up. If you get too high, they'll just pull you right back down. So I want you to notice the shape as you look down. Those first iFlies have their fans right underneath. In fact, let me show you an example of one of the oldest wind tunnels. I can get my mouse to go up there. Can you see that? Let me just duplicate this quick. Can you see that now?
Yes.
That was one of the first wind tunnels. Because they knew air is just going to go in a straight line. So it blows them up, and when they shut it off, it comes right back down again. Over the years, we've made them just a little bit safer, and we've enclosed our tunnel. So notice the grading down below. Notice how it gets narrower at the bottom. Let me explain to you the science behind what is happening there. Excuse me, I just lost control of my... Yeah, it's thinking. It's like, what are you doing? Okay, I'll continue, wait until that catches up to me. So why is it narrow on the bottom? Fans are on the roof. It's got to travel along the top, down the sides, underneath in the basement, back towards the tunnel, and up again. And all that distance. Do you think the air is speeding up or slowing down?
Speeding up.
Why do you think it's slowing down?
I thought it was speeding.
Because it's traveling further distances and it's becoming weaker.
Yeah, and what science concept is causing it to become weaker? Friction. It's rubbing against the sides, and then it's bouncing off the squares all the way around. So we didn't want it to get weaker by the time it got to you. So we wanted to give it an extra boost. And they used that shape to give it an extra boost. Think about being in your backyard with a garden hose. And when you turn on the water from your hose, gravity just pulls it right down. And did you ever put your finger on the opening of the garden hose? What happens to the water when you make the opening smaller? Yes. It goes harder. It goes faster. All of a sudden you can control the direction it goes in. Well, that is just like your garden hose with the thumb over it. We make the opening smaller, so we have to push all that air through a smaller opening. And then it comes out harder. Yes?
What is like the thing at the bottom, like not the wind tunnels, the like trampoline like thing? What's it made of?
It's made out of steel. It's super strong. You can park a car on it, and it won't break. Let me get back to where I was. Sorry, it just wasn't coming back to me.
And also another question.
Go ahead.
Anything on the top?
Let's go back to that diagram. Maybe that will help. Okay, can you see what I see? No, that's not what I want to show you. The next one. This one. So here are the 4 fans as they travel around the building, and this is the narrowing of the bottom of the tunnel. Back to science. Hot air rises. What do you think the temperature's like up here on our ceiling?
Very, 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 very cold.
Hot air rises. So if all the hot air is up there, what do you think you're gonna feel when you're up there? Hot. So do you think we wanna blow hot air at you? No. So as it comes down, and as engineers, this is all part of STEM careers, how to figure out how to solve this problem. As the air travels around, here and here is an evaporated cooler. When you send hot air through water, water through conduction absorbs the heat. And then the water gets warm and cool air comes out the other side. So not only do we squeeze it to give it an extra push, but we cool it down for you. So you're not falling through hot air. So, just like if you were jumping out of a plane, you have an instructor with you. Here, our instructors stand next to you and help you float. If you're gonna jump out of a plane, your instructor is strapped to your back. In both instances, gravity is always pulling. And then they're using all the air and space to be pushing up. We use 4 great big fans to push you up. Here is see if I can just get my speaker quick. I'm gonna show you a video of someone actually skydiving. Excuse me, sweetheart. I'm just gonna put on, there's not much to hear, but I'm just in case you wanna hear anything, I'm gonna put my speaker on. Okay, you can see the same body positioning as you will do in the tunnel. When you jump out of the plane, the very first force that's going to act upon you is gravity until you can get all that air underneath you to push you up. When you have equal amount of gravity pulling you down equals the force pushing you up, When we can get those things just as strong as each other, that is called terminal velocity. The gravity pushing you down equals the air pushing you up. Terminal velocity actually means, terminal means to end, velocity means speed. So we're stopping you from falling really, really fast and crashing into the planet Earth. We're slowing you down using the air. And when we can get them equal, then you can hover right there in the sweet spot. You'll all be hovering right about this height, about the height of the instructor. That's where you're all going to reach terminal velocity, where you get those two forces to equal each other. So why does body position count? Here is two pictures. Someone's using their body as a parachute because the air is coming from below. It's coming from the ceiling all the way around and coming up from below you. And you're going to use your body to catch as many of these arrows as possible. You want to catch as much air. That's going to help lift, well, slow it down at your speed. This person, if you just stood in the tunnel, only has a little bit of air touching. So that's not enough to get them to fly. So it's all about catching as much air as possible. And even the skydivers, as you can see, have the same position. Do they want to catch as much air as possible?
Yeah.
And what happens when the parachute opens? Do they catch more air or less air?
More.
So the more air they catch, they actually go up because now they're stronger than the gravity pulling them down. But that doesn't last long because gravity is always going to be pulling you down. But if you can look at the difference in the arrow sizes. The gravity's this strong. Once your parachute's open, the air pressure becomes greater, and then a parachute will lift you up before it comes down again. So here's that body positioning again. Who's flying and who obviously is not flying?
The girl in blue and the green and red.
Is not, because his only place the air is touching his is the bottom of his feet. This person has the whole body to catch air. So let's talk about these two. What direction do you think that person's going?
Forward. Oh, down.
Down. Why down?
Because he says that way.
Yes.
His head is facing down.
So why is he going down?
Because he's landing. Because he's upside down and less air is pushing up.
Because the air is only touching where? His head. You think that's enough to lift him?
No.
Notice this position. What direction do you think he's going?
Oh.
You're going to have lots of times to see our instructors give demos today. I want you to watch their bodies when they go up and watch their bodies when they come down. So, does anyone have any questions for me? Yes?
No one has gotten hurt here, right?
Nope. The youngest you can fly here is 3, and the oldest person to fly is 103. And he's waiting to his 104th birthday to do it again.
So which floor are we gonna do like the learn the commands on?
So I'm going to go back to this screen so I can show you once again where you're going to line up when you leave. And I misplaced where you're going to line up when you leave. So I'm going to just go back to this screen because it's always fun to watch the people fly. Excuse me. Somehow I got to be back here for this. Okay, so group 1 is going to leave me in just a few minutes. Sweetheart, can you just tuck your feet in? And you're going to go to this room here. You see where the red rope is? That's where you're going to line up in front of it. The fact that the door is closed, meaning there's already class in there. There's lots of people flying during the day, so while you're here today, you'll be here with other people who come in and do their flights. You're going to line up right there. He's going to bring you into the classroom and teach you the hand signals, okay? Any other questions for me? Yes?
He just does them like this. What does that mean? Like when he does like that. When he like moves his fists around like that.
So, these guys are obviously at a much higher level. So as they get to do flips and things, there are going to be hand signals that you're not going to learn because you're not going to be doing flips and things. But every time you come back to iFly, they keep a chart of what you've done. Today you've done the pre-flight class. Everyone has to do it. And then the next time you don't have to do it again. And then you can learn another skill. So every time you come back to iFly, you can learn a different skill. These guys are instructors and they're always improving their skills. Do these gentlemen who work here today actually jump out of planes? Oh yes, they do. So you can ask them about that as well. Any other questions for me about what you expect, the science or the tunnel? Okay, so let me just look at what time it is. It is 10:37. I want group 1 to stand up.